Welcome to the lecture on 2 degree of freedom system. So, we will discuss the principal modes of vibration. So, we were discussing a 2 degree of freedom system, and that has 2 masses and 3 springs, and both masses we assumed. So, we wrote the we made the free body diagram, we wrote the equations of motions, then we solved these equations, and finally we obtained the frequency equation. Then for certain assumption that both masses have the equal mass, both have the m1 equal to m2 equal to m, and the two springs are similar. So, k1 equal to k3 equal to k, and we found the two natural frequencies of the system. So, we had this system. So, we had this spring mass, this is spring mass, and this is spring. So, we had this is k, this is k, this is k2, and this is m, this is m. So, we have this system, and for this system we found that there are two natural frequencies. So, omega n1 we found root k by m, and omega n2 we found k plus 2 k2 by m. And for as we assume that the system is vibrating like x1 equal to x1 sine omega t and x2 equal to x2 sine omega t. So, at one time the system is vibrating with the any time with the same frequency, and at these two different frequencies we found that x1, the amplitude ratio x1 by x2, and we call it 1 because we are calculating for the first natural frequency or lower natural frequency. So, that is we got plus 1, and for this case when we calculate x1 by x2 second, so it is second natural frequency or higher one. So, we got it minus 1. Now, when we say that the system is vibrating with first natural frequency, so what does it mean here? It means that each and every point of the system they are vibrating with the same harmonic motion. So, if the system is vibrating with first natural frequency, the both the masses are vibrating with the omega 1 omega n1 equal to root k by m, and when the system is vibrating with the second natural frequency omega n2, both the masses are vibrating with omega n2, that is root k plus 2 k2 by m. And when the system is vibrating with first natural frequency, the amplitude ratio is plus 1, means the both masses have the equal amplitude and they are in phase. So, if one mass is going up, the second mass is also going up. If one mass is coming down, the second mass is also coming down, and during that oscillation or that motion, their ratio x1 by x2 is constant and it is equal to 1. So, if x1 is from its equilibrium position at any instant of its vibration from equilibrium position, if x1 is 5 mm, then x2 will also be 5 mm. Then about omega n2, if it is vibrating with the second natural frequency omega n2, we are getting that the amplitude ratio x1 by x2 is same that is 1, but there is negative sign, it means they are out of phase. So it means that if x1 is going up, x2 will be going down. Although the x1 with its equilibrium position, it will be, if 5 mm upward, the x2 will be 5 mm. So if it is 5 mm upward, it is 5 mm downward at that instant of time. So they will be out of phase. Now how can we represent this? So these are called the mode shape. Mode shape. This is also mode shape. So this is the first mode shape, as it is corresponding to the first natural frequency, the lower one, and this is second mode shape, as it corresponds to the second natural frequency omega n2, and the condition when each point of a system vibrates with the same frequency, that is called the principal modes of vibration. So these both modes, they are the principal modes of vibration. So they are the principal modes of vibration. Because at any frequency, if the complete system is vibrating with omega n1, each particle will vibrate with the same frequency. Both masses will vibrate with the same frequency. Now if we take the first mode, so the first mode and this is my system. Okay. Now suppose this mass is going, I am representing the motion of this mass. So if this is the equilibrium point of both the masses, so these are their equilibrium points, and that I am representing here. So if one mass is here, the other mass will also be here, and these points are fixed. So we will have these and this, and so this is x1, this is x2, and x1 by x2 equal to plus 1. Now suppose this mass is now at maximus, now they come return, so come back, so they will be making like shape like this, like this, like this. Again this amplitude will be, the ratio will be same, so they will be equal. So it means they are making this. So this is the first mode, this is mode shape, the first mode shape, and this says that both the masses, they are in phase because both are in the same site, the same amplitude. What we see that this spring K2, when both masses, the first mass is going down, second mass is also going down, first mass is coming up, second mass is also coming up with the same amplitude. So it means that the spring K2, that middle spring, that is neither compressed nor stretched. So it is moving with these two masses as a rigid body. It is not getting either any compression or extension. So it is just translating as a rigid body. So it means that this spring is ineffective in this case. There is no role of this spring. If we remove this spring, what will happen? So if we remove this spring, so we will have a system like this. and a system like this K, and this is M, this is M, this is K, and both will, this will go this side, this will go this side, then when they will up, they will up. So, they will vibrate with the same, they can vibrate independently with the same natural frequency, and you see the natural frequency here omega n equal to root k by m, here omega n equal to root k by m, and that is why this first natural frequency is coming root k by m. Now, when we talk the second mode shape, so if we have this system, so this is K, K, K2, M, M. Now, we are saying that it is the second mode. So, this is the second mode, and it says that x1 by x2 equal to -1 means they are out of phase. Means if one is going, if from equilibrium position one is at 5 mm downward, the second mass is 5 mm upward. It means that if this mass is 5 mm here upward, this mass will be 5 mm downwards, the other side, or if this is this side, this is this side. So, what will be the mode shape? So, this is the mode shape. So, this is x1 and this is x2, and we see that x1 by x2 equal to -1. Now, in this case, so this is the point corresponding to the center of this spring, middle spring. We see that this point is always grounded, it is fixed. So, it is fixed means if we make the system like this, so this is K, this is K, this is M, this is M. Now, this spring is cut into half, because at middle of this it is, this point is fixed. So, it is cut into half because this point is grounded. So, if we half the spring, the stiffness will be twice doubled. So, it is 2 K2 and this is 2 K2. So, now these systems are independent. So, what will be the frequency? Omega n equal to under root. So, they are in parallel. So, this K and this K is parallel. So, they will sum. So, K plus 2 K2 by M, and this is also K plus 2 K2 by M. And so, these both system, they are like vibrating as a independent, these systems, to these systems, and this is what the natural frequency number 2. So, now here we understand that how these systems vibrate when they in different modes, what is their meaning. So, a system will vibrate the first in the first mode if we give the initial condition for the first mode. So, initial condition for the first mode should be like we disturb the system, both the masses we pull in the same direction and equal amplitude, and then we release them. So, if we give this kind of initial condition, the both masses will vibrate with the first natural frequency and they will form the first mode shape. But if we give them initial condition according to the second mode shape, like if I give the first mass 5 mm deflection upward and second mass 5 mm deflection downward, and then I release them. So, they will start the free vibration with the second natural frequency and second mode shape they will make. Now, suppose I am giving unequal initial conditions, like I am giving x1 as 5 mm upward and x2 not 5 mm but 7 mm upward, then these initial conditions will be neither of first mode nor second mode. So, there will be a mixture of the modes. So, the both modes condition will be superimposed, and in that case the response of the system will be not as a principal mode of vibration, but it will be the superposition of the both modes. And so, what will be that? So, here x1 will be x1 dash cos, so omega n1 t plus x1 double dash cos omega n2 t, and here x2 will be x2 dash cos omega n1 t plus x2 double dash cos omega n2 t, and here x1 equal to x1 dash plus x2 dash, that is the initial condition for mass m1, for the first mass, and x2 equal to x2 dash plus, so this is x1 double dash and this is x2 dash and x2 double dash. So, initial condition or initial deflection of the mass, the second mass, we say here second mass, and these, because they are both these are the amplitude of the same frequency. So, here x1 dash by x2 dash, they will be equal to x1 by x2 first mode, and x1 double dash by x2 double dash, they will be equal to x1 by x2 the second mode. Okay, so let us take one example. So, here it is a 2 degree of freedom system, the same system where m equal to 9.8 and k equal to 8820 and k2 equal to 3430. So, we have to find the resultant motions m1 and m2 for the following cases. So, in the first case we are giving both. So, we are giving x1 equal to 5 mm downward, and so both we are giving 5 mm downward. Now, here omega n1 equal to root k by m, and that is equal to 8820 by 9.8, and omega n2 equal to k plus 2k2 by m. So, that is equal to 8820 plus 2 into 3430 by 9.8. So, this is 30 radian per second and this is 40 radian per second. Now, we have x1 equal to x1 dash plus x1 double dash equal to 5 and x2 dash plus x2 double dash equal to 5, and we know that the first mode shape. So, x1 dash by x2 dash equal to plus 1, the first mode shape, that is corresponding to the first natural frequency. This implies that x1 dash equal to x2 dash, and second mode shape x1 double dash by x2 double dash equal to minus 1. So, x1 double dash equal to minus x2 double dash. Now from these two equations, so in this equation, so x2 dash is equal to x1 dash and x2 double dash is minus x1 double dash equal to 5. So we solve these two equations, so we add and this will be cancelled out. So this means 2 x1 dash equal to 10, this implies that x1 dash equal to 5 and that is equal to x2 dash. Now we put the value of x1 dash here and we get x1 double dash equal to 0 and this is equal to x2 double dash. So means that what will be the equation, the resultant motion. So x1 equal to x1 dash is 5 cos omega n1 t, omega n1 is 30 t. Now x1 double dash is 0, so that part will be not here, and x2 equal to x2 dash, so x2 dash is 5 cos omega n1 t 30 t, again x2 double dash is 0. So we see that now you see here x1 by x2 equal to 1 and omega equal to omega n1. So this is the principal mode of vibration and first mode of vibration, and both masses have the harmonic motion with the same frequency and same amplitude. Now we take a second case when there will be the unequal initial conditions. So we have the second case when mass m1 is displaced 5 mm downward and mass m2 is displaced 7.5 mm downward. So we have now x1 equal to, that is x1, so x1 equal to 5 and x2 equal to 7.5. So here we have 7.5 and so here x2 will have 7.5 and these conditions will be satisfied as we are these are principal modes vibrations. So we will have these conditions. Now if we put, so we remove this, so we will have here x1 dash and here it is we put here. So x2 dash is x1 dash because x2 dash we put, and x2 double dash is minus x1 dash double dash and that is equal to 7.5. Now we add these two equations. So what we will get, 2 x1 dash equal to 5 plus 7.5, it is 12.5. So x1 dash is 6.25. Now we put the value of x1 dash here and we will get x1 double dash to 6.25 plus x1 double dash equal to 5. This means x1 double dash equal to 5 minus 6.25, that is minus 1.25 and that is equal to minus x2 double dash. This implies that x2 double dash equal to 1.25. So what will be x1? So x1 will be x1 dash and x1 dash is 6.25 cos omega n1 t, that is 30 t, and x1 double dash is minus 1.25. So here we will have minus 1.25 cos omega n2, so cos 40 t because omega n2 is 40. Then what will be x2? That is x2 dash. So x2 dash is equal to x1 dash from here. So x2 dash is 6.25 and cos omega n1 t, and here plus x2 dash, double dash, so x2 double dash is 1.25, so plus 1.25 and cos omega into t. So what we see that when we are giving different initial conditions or different amplitude of initial condition to the masses, they contain both the modes. So the resultant is the superposition of the both frequencies and both the motions. So we stop here the lecture, and thank you for attending the lecture, and see you in the next lecture.